Dear students, I welcome you to the lecture on job sequencing problem by Johnson algorithm. At the end of this video, you will be able to apply Johnson's rule to solve job sequence problem with 2 missions and 3 missions. What is job sequencing? Job sequencing is the process of determining the optimal order in which jobs should be processed on one or more missions. Job sequencing will minimize the total processing time and ideal time, by which it will increase the efficiency and productivity. Let us try to understand the terminology of job sequencing with some example. Let us assume that you want to print and bind operations research material. So you went to Xerox machine and asked how much time it will take, and he said 5 minutes for printing and 2 minutes for binding. Then the total time it will take to complete the order is called as elapsed time. The elapsed time here is 5 plus 2, 7 minutes. And also when the printing machine is printing for 5 minutes, at that time the binding machine will be idle. So idle time of binding machine will be 5 minutes. And when the binding machine is doing binding for 2 minutes, the printing machine will be idle. So the idle time of printing machine will be 2 minutes and binding machine will be 5 minutes. In this way, for any job sequencing problem, we need to calculate the elapsed time as well as idle time. Let us try to understand the importance of job sequencing with one another example. Let us consider that one of your friend also is coming for taking the Xerox and binding. Then you and he wanted to print C++ material. Then you went to Xerox shop person and asked how much time it will take, and he says the book 1 it will take 5 minutes for printing and 2 minutes for binding, and book 2 will take 1 minute for printing and 6 minutes for binding. Then you will be asking how much total time it will take to complete these two books. Then he will say, if I keep the sequence first book first and second book second, it will take 13 minutes. And if I change the sequence second book first and first book second, then it will take 9 minutes. Then how it is possible? When you change the sequence of jobs, you will be able to decrease the elapsed time. Let us see how it will be possible. Now let us make a table in which we will make the job sequencing 1 and 2, and here we will also need to note the printing machine and binding machine in time and out time for every job. Let us say he is first doing the job book 1. Then book 1 will take 5 minutes for printing, so it is the printing machine will start in time 0, and then it will take 5 minutes for printing the first book, so out time will be 5 minutes. So because it is taking 5 minutes for printing, so it is starting at 0 time and it is completing its task after 5 minutes. After 5 minutes only, the material will go to the binding machine. So the in time for binding machine will be 5 minutes, and after 5 minutes only it will start. Then it is taking 2 minutes for binding, so 5 plus 2, 7 minutes. That means within 7 minutes book 1 will be completed. Then we will come to book 2. It will take 1 minute for printing, 6 minutes for binding. Then the in time for book 2 for printing machine will be up to 5 minutes. Book 1 it is getting printed, then the printing machine will be free. Then it will start its job after 5 minutes. Then it will take only 1 minute for printing, so 1 plus 5 it will be 6 minutes. That means within 6 minutes total printing will be done with the printing machine. Then even though it completed printing within 6 minutes, after 6th minute the binding machine is doing binding of first book, so we can't assign here. So it need to the book 2 material need to wait till binding machine get free. This is called as job waiting time. So here 1 minute time job should be waiting, and then after 7 minutes the binding machine will start working on a book 2. Then it will take 6 minutes to complete binding. So 7 plus 6, it will be 13 minutes. So here the elapsed time is 13 minutes. Now let us consider the waiting time of printing machine. The waiting time of printing machine, here within 6 minutes the printing machine completed its task, but it taken up to 13 minutes the printing machine should be waiting. That means the waiting time or ideal time of printing machine will be 13 minus 6, that is 7 minutes. Now the binding machine, initially it is waiting for the material to come here, so ideal time of binding machine will be 5 minutes. So the total ideal time of printing machine is 7 minutes and ideal time of binding machine is the 5 minutes. Now let us consider the changing the sequence of the job. Here, by changing the sequence of the job, we will try to calculate the elapsed time. Now, I am keeping the job sequence as first second book and then first book. Then let me calculate the elapsed time, and here the printing machine and binding machine, the in time and out time will be calculated and written here. Now first I am starting the second book, so at 0 time the second book is starting, and because the printing time is only 1 minute, the printing will be over after 1 minute, within 1 minute. Then after 1 minute it will go for binding, then and it will take 6 minutes to complete. Then 1 plus 6, 7 minutes. Within 7 minutes the book 2 will be completed. Then book 1 will start printing after 1 minute. After 1 minute printing machine is free, so we can assign book 1 for printing. So after 1 minute the printing machine will start printing a book 1, and it will take 5 minutes to complete. So total 1 plus 5, 6 minutes. That means within 6 minutes the printing machine will complete its task for both book 1 and book 2. Then even though within 6 minutes it completes its task, it need to wait for 1 minute, and after 7 minutes only the binding machine will be free. Then after 7 minutes the book 1 will be given for binding. Then it will take only 2 minutes to complete, so 7 plus 2, 9 minutes. Now according to this table, the total elapsed time for completing these two books in the sequence 2 1 is 9 minutes. Now let us consider the ideal time, and ideal time of printing machine will be 9 minus 6, that is only 3 minutes, and ideal time of binding machine will be only 1 minute. So ideal time also reduced and the total elapsed time also reduced, because we change the sequence of the jobs. That is the importance of job sequencing. When we organize the jobs in a proper sequence, then we can able to reduce the total processing time, that is elapsed time, as well as idle time, such that it will increase the efficiency and productivity. Now in the previous example we saw only two jobs. Let us say there are 5 jobs or 6 jobs with 2 machines. Then how to solve these problems? That we can be easily solved, or can make the job sequence by Johnson algorithm for n jobs 2 machines. And the Johnson algorithm says record processing time for all jobs on both machines, identify the small time among all jobs across both machines, sequence the job. That means initially we need to write each and the processing time of each job with respect to the each machine. Then identify what is the smallest machining time, or the smallest the value among all the machines, among all the jobs. Then If that minimum value is belongs to mission 1, then keep the schedule as a first. If the minimum value is belongs to mission 2, the schedule the job at the last. If there is a tie on mission 1, schedule the job with a short time on mission 2 first. If there is a tie on mission 2, schedule the job with the short time on mission 1 last. Let us see some examples such that we can able to understand this algorithm very easily. Let us solve this problem by using job sequencing problem. There are 5 jobs, each of which must go through the 2 missions A and B in the order AB. Processing times are given in the table below. Determine a sequence for 5 jobs that will minimize the elapsed time. Also calculate the elapsed time and idle time. So now let us try to apply the Johnson's rule here. Now these are the red color numbers are the orders, and A is the mission and B is the mission B, and these are the processing time. Out of all this processing time, identify what is the smallest number. The smallest number is 1. Then you make the job sequence. There are 5 jobs you need to make in sequence, so make a 5 blocks. And then if any small value is belongs to mission A, that we need to schedule it first. If any small value is belongs to mission B, that we need to schedule it at last. Now let us try to identify the smallest value. This is the smallest value that is belongs to mission A, and that we need to schedule it first. So which one we need to schedule it first? The second order or second job we need to schedule it first. Then the next smallest value is the 2, which is belongs to order 1, that we need to schedule it at the last. Then we are scheduling that into last because it is belongs to mission B. Then next smallest value, so these 2 are over, so we just put cross mark, and remaining 3 orders are there. Among these 3 orders, the smallest value is 3, and this 3 is belongs to mission A, and that we need to keep it in first. Then 4 will be coming here. Then the next smallest value among these, the 2 orders are 4, that is belongs to mission B, that we need to keep it at last. Then the left out number is or order is only 3, that we will keep at the middle. So now this is the sequence of jobs. So 2, 4, 3, 5, 1. And by keeping this job sequence, we need to calculate the idle time and elapsed time. Now let us make a table. In that we will keep the all jobs, 5 jobs in sequence, that is 2, 4, 3, 5, 1, and mission A and mission B, and what is the in time and out time, let us try to see. Now we need to start with mission 2. So if you start with mission 2, so the mission 2 will take we will start with order 2. So order 2, it will take 1 minute on mission A and 6 minutes on mission B. So here the in time will be 0, and it will take 1 minute, so it will become 1 minute out time. And for mission B, in time will be after 1 minute, then, and it will take 6 minutes here, so then it will be taking 1 plus 6, it is 7 minutes. Then we will go to the order 4. Order 4, it is taking 3 minutes as the processing time, so then it is starting after 1 minute, because after 1 minute mission A is free. Then it is taking 3 minutes, 1 plus 3, it will be 4. Then even though it is free after 4 minutes, it need to wait, because after 4th minute the mission B is working on the order 2. So the here order 4 can be processed only after 7 minutes, because up to 7 minutes mission B will be engaging with the order 2. Then here the in time will become 7 minutes. Then it will be taking the 8 minutes for on mission B, so 7 plus 8, it will be 15. Then we will come to order 3. Order 3, so these 2 orders are over. just we can make into mark here. And these are into mark, and or otherwise you can just make a mark. These two are over. Sorry, this is over. 2 and 4 are over, 5 is not over. And now let us start a third job. Third job will start after 4 minutes. So here it will be 4, and it will be taking 9 minutes to on mission A. Then 4 plus 9, it will be 13 minutes. Then after 13 minutes it need to wait till 15 minutes, till it get 15 minutes. Then after 15 minutes only job B will be starting, because up to 15 minutes job B will be free, will be busy with order 4. Then it will be taking 7 minutes. 15 plus 7, 22. And then we will come to order, so this job is over. Then next we are coming to job 5. Then job 5 will start after 13 minutes, and it is taking 10 minutes here. 13 plus 10, 23. Then here now up to 22 minutes job B will be engaging with the order 3, but after 23 minutes it will be free. So here after 23 directly we can assign here. Then it will be taking 4 minutes, so total 27 minutes. Then we will finally start order 1. Order 1 will be starting after 23 minutes. Then it will be engaging for 5 minutes, so 23 plus 5, 28. Then here again the job 5 is already over by 27 minutes, so here we can comfortably the mission B can be used for order 1, and it will take 2 minutes to complete. So finally the total job will be completed within 30 minutes. So here the elapsed time is 30 minutes, and ideal time of mission A will be 2 minutes. Where it is waiting? Actually nowhere it is waiting, because it is the first mission, and the total elapsed time is 30 minutes. So 30 minus 28, it will become 2 minutes. Then if you see the mission B will take up to 30 minutes, but here initially it is waiting for 1 minute here. So here 1 minute it is waiting, so 1 minute here, and there is no waiting time here, there is no waiting time here, but there is 1 minute waiting time here, because it completed within 22 minutes, but it taken another job only after 23 minutes, so 1 minute it is waiting here. And again it is completed its task within 27 minutes, but it is waiting for the job another order for 1 minute. So total 1 2 3 minutes it is waiting. So the total waiting time will be ideal time or waiting time will be 3 minutes. That is how we will be solving the problems. Now let us see how we can apply this Johnson's algorithm for n jobs with 3 missions. And according to Johnson's algorithm, we need to first check the applicability. Algorithm applies if the shortest processing time on mission A or C is greater than or equal to maximum time on B. And combine, if it is applicable, then we can combine the missions, create two hypothetical missions, and here the B is having the maximum time is less than or equal to the shortest time on mission A or C. So then this mission will become the common for G and H summation. So G will become A plus B, and H will become the C plus B. And apply the algorithm for n jobs 2 missions for G and H, considering G is one mission and H is another mission, and solve as usually. Once we get the sequence, then we can able to apply this method for finding the elapsed time or job sequencing. Let us see one problem. There are 5 jobs, each of which must go through the 3 missions A, B and C in the order A, B, C. Processing time are given in the table below. Determine the sequence for 5 jobs that will minimize the elapsed time. So now here there are A, B, C 3 missions are there. Then according to Johnson's rule for 3 missions, we need to first check the applicability. So if you check the applicability, first we need to see what is the maximum time in A. So the maximum time in A is 11 minutes, 11, and maximum time in B is 6 minutes, maximum time in C is 9 minutes. And again let us see the minimum time. The minimum time in A is 6 minutes and the minimum time in B will be 2 minutes. Minimum time in C will be 4 minutes. Now if you properly observe, the maximum time processing time of mission B is 6, that is less than or equal to the minimum time in A. So this B is the common for A and C for combining. So the applicability is applying here, so we can able to combine it. So then we need to combine the missions, create two hypothetical missions, that is G is equal to A plus B and H is equal to B plus C. Then the new missions G and H will be coming like this. G is equal to A plus B, so A plus B for order 1 will be 8 plus 5, that is 13, and for order 2 10 plus 6 16, 6 plus 2 8, 7 plus 3 10, 11 plus 4 15. The same manner for H, B plus C, that means the B plus C, and it is 9, and 6 plus 9 15, 2 plus 8 10, 3 plus 6 9, and 4 plus 5 it is 9. So now these three missions we have converted into 5 orders 2 missions. Now we can apply the n jobs with 2 missions rule we can apply for finding the job sequence. Now let us try to see the job sequencing. Now we will take this G and H, we will consider as two different missions, and then we will try to find the job sequencing. According to Johnson's rule, we will first write the job sequencing, and there are 5 jobs we need to keep in sequence. So we will make 5 blocks, and if the minimum value belongs to mission G, we will write first, and if the minimum value belongs to H, that we will schedule it last. Then now among all this processing time, we will first find out what is the smallest value. So 8 is the smallest value, that is belongs to mission G, then that we will schedule it first. Then the next value will be 9. So 9 at 3 places in job order 1, order 4 and order 5 also. Now among these 3, when there is a tie with the mission B, we need to see with respect to the mission A values. Now here if you observe the mission A processing value, here 13 and here 10 and here 15. Among this 13, 10 and 15, the 10 is the smallest one, so that we need to first the schedule it. So this 9 is belongs to H, that we need to schedule it at last. Then the fourth will become last. Then the next smallest value here is 9 only, but the smallest value in G also, if you consider, the order 1 will become the next schedule. This is belongs to the H, so we will be scheduling that in the last. So that means next to 4 it becomes 1. Then the next smallest value will be the 9. Again here it is 15, so that is belongs to 9 is belongs to H, so we will be scheduling that at the middle block, and left out order is only 2, that we will be scheduling at 2. Now we got the job sequencing, that is 3 2 5 1 4. Now if you follow the job sequencing in this order, you will get the elapsed time. Let us see that. Now let us consider A, B, C, all these 3 missions, and we already know the job sequencing. So list the job sequencing as a 3 2 5 1 and missions A, B, C with in time and out time with all 3 missions. Now let us try to see how the jobs are working. Now let us first try to see with the order 3. Order 3, it is taking 6 minutes on mission A. Then it is starting at 0 time, and it will take 6 minutes to complete. Then after 6 minutes the mission B will start. Then it will be taking 2 minutes here. then 6 plus 2 8, then it is taking 8 minutes on mission C, so 8 plus 8, it becomes 16. Then order 2 will be starting. Order 2, the processing time will be 10, so here the same time will come here because it's the first mission. Then 6 plus 10, it becomes a 16. So and then here the in time will become 16, even though it is free from 8 minutes. Then the next it is taking 6 minutes on mission B, 16 plus 6 22. Then it is taking 9 minutes here, so 22 plus 9, it becomes a 31. So then order 5 will be starting. So here 16 minutes, after 16 minutes order 5 will start. Then it is taking 11 minutes on mission A, then 16 plus 11 27. Then here it completed its job within 22 minutes, so here the 27, after 27 the mission B will start. Then it will take 4 minutes on mission B, so 27 plus 4 31. Then on mission C 5 minutes it will take, so here the 31, there is no waiting time, within 30 minutes 31 minutes it's completed its job, so we can directly assign 31 plus 4 5, then it will become 36. Then we will go to the order 1. It will take the 8 minutes here, and the initial time will be 27, and 27 plus 8 35. Then here 31, but 35 here will put because the 35 is the maximum time. Then 35 plus 5, so 40, 40 plus 4, the 44, because here 40 is the biggest number, so we need to directly keep the maximum value here. Then here 35 will keep here, and for job 4, and 7 minutes it will wait, that is 42 plus 3, so 43 plus 3 45. Then 45 plus finally 6, it becomes 51. So here now the total elapsed time for completing this all orders on these 3 missions will be 51. So now let us try to calculate the idle time. So if you see the idle time on mission A, 9 minutes. So here there is no idle time anywhere because immediately jobs are starting, but within 44 minutes it completed its task, but the total elapsed time it is 51. So that means the 51 minus 42, 9 minutes mission A is idle, and mission B initially it is idle for 6 minutes. So and then here within 8 minutes it completed its job, but till it get the next job to do, till that time it need to wait. So that means here there is a difference of these two number, that is 8 minutes, still it is waiting, so 6 plus 8. And again here it in the third order it completed second order within 22 minutes, but it is waiting till it get the third order, that is 27 minutes. 27 minus 22, the 5 minutes it is waiting plus 5. Then again here 35 minus 31, there is the 4 minutes it is waiting plus 4, and here 42 minus 40, 2 minutes it is waiting. If you add all these things, it will become 31. That means the mission B is waiting the 31 minutes in order, and 31 minutes including 5 minutes here. So here it completed its total printing, or the mission B completed its total performance within 45 minutes, but still it need to wait till it becomes a 51. So here there is a 6 minutes again here. So the total, if you calculate, it will become 31 minute. Then if you come to mission C, and mission C initially it is waiting 8 minutes till it gets the job, and then here if you observe the difference, 22 minus 60, there is a 6 minutes, and 31 minus 31, there is no waiting time here, and 40 minus 36, there is a 4 minutes waiting time, and here 45 minus 44, there is a waiting time of the 1 minute. So if you add all these things, it becomes a 19 minutes. So this is how we can able to calculate the idle time of each mission. And finally I wanted to conclude that Johnson algorithm offers a systematic method to minimize total processing time for n jobs on 2 or 3 missions. It reduces idle time ensures smooth transition between missions. This algorithm is ideal for manufacturing operations, helping optimize time, increase productivity, and reduce cost. Thank you.